We've been using some of Java's primitive types, but we really need to know some more details about them. Zumi,
Yes?
what's the definition of a primitive type?
A primitive type is one that the compiler knows about, so it knows how much space it requires.
Correct. That means that primitive types have predefined, fixed sizes. The limit on the space they are given means that they are limited in what values they can hold. Here is a chart showing the limitations of all of the primitive types in Java. The simplest of these is Boolean. A variable that is declared to be Boolean can only hold two values, true or false. There are 4 primitive types that store integers. They vary in how much memory gets allocated to them, and that changes the ranges of values that they can store. We typically use int because its range is big enough that we don't usually have to worry, and memory is pretty cheap.
Later in your career, you'll find that even if you declare something to be a byte, the way memory is addressed may make it take more than a byte anyway.
True. And most of the classes that come with Java use ints, so using something other than int can cause unnecessary type conversions. The general rule, for integers, use int unless you really need something else. When we store a number, we must have a place to hold whether it is negative or positive. Essentially, we need to be able to store whether the number has a negative sign. We store that as a 1 or a 0 at the left side of the integer. If we pretend that an integer in our machine can hold 3 decimal digits, so we have a range of negative 999 to positive 999, negative 999 would be stored as 1999, and positive 999 would be stored as 0999. There's a weird side effect to the fact that integers have fixed sizes and that they store the negative sign as a bit on the left of the number. Suppose again that our range of integers is negative 999 to positive 999. What happens if we add 130 to 899? The result is 1029. But wait, that 1 means the number is negative, so 1029 is negative 29.
Wait, we added 899 and 130 and got negative 29? What kind of stupid machine is this?
Yep, that's the way it works, and I agree that seems pretty awkward. This is called overflow because we essentially carried into the sign bit. The number overflowed the amount of space we had for it. The amazing thing is that the machine doesn't worry about this at all. You won't get an error of any type. Suddenly, a number that should be pretty big goes negative, and that's your only clue that something went wrong. Notice that the 4 different types of integers will overflow at different values since their ranges differ. If one overflows, we can often recover by changing its type to the next bigger type. In addition to the 4 integer types, there are 2 types that store doubles. To understand their differences, we need to talk about how the computer stores a real number. The computer stores real numbers similarly to scientific notation. In scientific notation, any real number can be written with the decimal point to the left of all of the digits if we remember how many positions off it is. For example, 12.33 can be written as 0.1233 times 10 squared. To recreate the value, we only have to store the 1233 and the 2, which are both integers. Since there's a multiplier involved, real numbers don't have a range. Instead, they vary in their precision.
Think about it this way. The mantissa is a fixed size integer, so it has a fixed range. When we use the exponent to move the decimal point, we can get almost any value. But the resulting number can only have non-zero digits in the part of the number where the mantissa ends up.
The primitive type double has more space for the mantissa and for the exponent than float, so it has higher precision. Even though it takes more space, we usually use double. The Java API usually uses double, so matching that means we will have fewer type conversions. When we do scientific notation, we raise 10 to the exponent because that's what moves the decimal point in our numbers. Multiplying by 10 moves the decimal point to the right by 1 position, and dividing by 10 moves the decimal point to the left by 1 position. However, the computer thinks in base 2, so the computer calculates by raising 2 to the exponent. For example, if our mantissa is 125 and the exponent is 3, The number we are representing is 125 times 2 to the third power. 2 to the third power is 8, and 125 times 8 is 1,000. As another example, suppose our mantissa is 4, and the exponent is negative 3. That is 4 times 2 to the negative 3. 2 to the negative 3 is 1/8, so the number we are representing is a half. So, Java has a set of types that the compiler knows about, and we call these primitive types. The Boolean type allows a variable to hold either true or false. There are 4 primitive types, and they vary in how much memory they are given, and that means that they differ in the range of numbers each can represent. Most of the time, we use int because it's consistent with the Java API and gives us a big enough range. The risk with integers is that because they are fixed size, they can overflow. When this happens, a number that should be very large, too large to hold, appears to be a negative number because it has overflowed into the space where we store whether the number is negative.
Truth be told, we can overflow negative numbers too. That also switches the sign bit, so a number that should be really negative becomes positive. Sometimes people call this underflow.
Interesting tidbit there. Java also has 2 types that hold real values, double and float. The way they store real values is by storing 2 integers of scientific notation, the mantissa and the exponent. Of the 2 types, double has more precision because it has more space to store those integers. Like int, most of the time we use double because it's compatible with the Java API and causes fewer type conversions. The only primitive type left to talk about is char, and we'll talk about that in the next video.